An immersion heater rated 1000 watt 220 volt is used to heat 0.01 meter cube of water. Assuming that the power is supplied at 220 volts and 60% of the power supplied is used to heat the water, how long will it take to increase the temperature of water from 15 degrees centigrade to 40 degrees centigrade? So here we have to find out the resistance first. So R equal to V square upon E. So V is 220 square divided by P is 1000. So this will give 48.4 ohm. Now, mass of water is volume into density 0.01 into 1000. So this will give 10 kg. And from the principle of calorimetry, heat given Q equal to ms delta T, where delta T is change in temperature and it is 15 to 40, that is 25 degrees centigrade. Specific heat of water is 4200 joule per kg. So that are right here. So now, so S is 4200 joule per kg per degree centigrade. And heat we can calculate. So first, let's write it. Q equal to M. M is given as 10 kg. Specific heat is 4200. Change in temperature, and that is 25. So this will become 105000. Now, 60% of heat is equal to this much. So heat produced from Joule's law of heating, heat is given by I square RT, but it's a 60% is used for heating the water. So 60 by 100. The two must be equal, this heat and this heat. So we can write 60 upon 100 into I square. That is V upon R is I. So V is 220 and R we have found 48.4. So V square upon R, V square, I square R can be written as IR times I, so this is VI, and this can be written as V upon R. So this is V square upon R times time. Must be equal to this much, 1050 followed by 3 more zeros. So 000. We have to find the time. So we put the values 1050 times 100 times 48.4 divided by 60 into 220 into 220. If we simplify, we will get 1750 seconds. That's our answer. Now, question number 10. An electric kettle used to prepare tea takes 2 minutes to boil 4 cups of water. That is, each cup contains 200 cubic centimeter of water. If the room temperature is 25 degrees centigrade, and cost of power consumption is given as 1 rupees per unit, then we have to calculate the cost of boiling 4 cups of water, and then what will be the corresponding cost if the room temperature drops to 5 degrees centigrade. So here, in first case, temperature rises from 25 to 100 because boiling point of water is 100. So temperature difference delta T will be equal to 75 degrees centigrade. And mass of water is 4 times 200, that is 800 gram, which is equal to 0.8 kg and specific heat of water is 4200 joule per kg per degree centigrade. So, and it is to be expressed in terms of units kilowatt hour. 1 kilowatt hour is equal to 1 unit, which is equal to 3.6 into 10 to the power 6 joule. So here we have to calculate heat required, heat equal to ms delta T. We put the values. So mass is 0.8, specific heat is 4.00 into change in temperature is 75. So this will be equal to 252 joule. So number of units will be equal to this value 252,000 divided by value of 1 unit, that is 3.6 into 10 power 6. So this will come out to be 0.07 units, and the rate of 1 unit is 1 rupee, then cost will be equal to 0.07 units. That is 7 paise. Now, in second case, if temperature starts from 5 degrees centigrade, it goes up to the boiling point, that is, there will be temperature difference of 95 degrees. So here, heat will be equal to M is same 0.8, specific heat is 4200, temperature difference will be 95 this time. So we have to find out number of units. This will be in joule, and if we divide it by this value, that is 3.6 into 10 to the power 6, so we will get number of units, and that would be 0.0885. And the cost of 1 unit is ₹1, so it will be 8.8 paise, which will be equal to 9 paise. Now, question number 11. Here, the coil of an electric bulb takes 40 watt to start glowing. If more than 40 watt is applied, 60% of the extra power is converted into light and rest into heat. Bulb is rated 100 watt, 220 volt. Find the percentage drop in light intensity at a point if supply voltage is changed from 220 volt to 200 volt. So here, bulb is 100 watt. So excess voltage will be 40 is the limit. So beyond which will be 60. And then, so power converted into light is 60% of power exceeding 40 watts. So here, this is 60 watt, 100 minus 40. So that will be 36 watt. Suppose this equation one. Now, resistance of bulb R equal to V square upon T. So voltage is 220. So 220 square divided by 100, that is 484 ohm. When voltage is 200, it drops to 200. In that case, what is power? When voltage drops to 200, then power equal P1 equal to V square upon R, that is 200 into 200 divided by R, 484. So this will give 82.64 watt. So this time excess power, the limit is 50 watt, and this time power is 82.64 So excess power will be 82.64 minus 40. That is 42.64 watt. And 60% of it will convert into light. So power converted into light. 60%, 0.6 into 42.64 equal to 25.587 watt. Initially, it was 36 watt, and now it is 25.587 watt. So, change in power, delta P will be difference of the two. 36 minus 25.587. That is 10.413 watt. Now, percentage drop. So, we have to make comparison from this 36 watt. So, percentage drop in intensity will be changed, that is 10.413 into 100 divided by 36. So this will be equal to 28.9%. Now, next question. A 2 ohm resistor showed that the figure is dipped into a calorimeter containing watt. That is 2 ohm. This is 6 ohm, which is outside. This is 1 ohm. This is 6 ohm. The heat capacity of calorimeter together with water is 200 joules per Kelvin. If the circuit is active for 15 minutes, what would be the rise in temperature of the water? Suppose the 6 ohm resistor gets burnt, what would be the rise in temperature of the water in next 15 minutes? So here, let's find out what is total resistance. These two resistances are in parallel in series with 1 ohm. So total resistance or total will be 1 plus 6 into 2 divided by 6 plus 2. So this will be equal to 5 by 2. Now we can find the correct. I will be 6 divided by 5 by 2. That is 12 by 5, which is 2.4 ampere. Now we can use loop law. Suppose I current is coming from the battery, and this is suppose I2, and this is suppose I1. So we can make the equation. So 6 equal to, here I current is passing through 1 ohm, so it will become 2.4 times 1 plus I2 times 6. So 2.4 can be shifted to LHS, so we will be left with 3.6 equal to I2 into 6, from where we get I2 equal to 0.6 ampere. Then I1 will be equal to I minus I2. So I is 2.4, 2.4 minus 0.6, so 1.8 ampere. Now, heat produced. So heat will be produced into this 2 ohm resistor. So heat produced H1 equal to I square. So here I1 square times R is 2 into time is 15 minutes, 15 into 60. And I1 is 1.8. So 1.8 square into 2 into 15 into 60. And that will be equal to 5832 joule. Now rise in temperature. Here in our question it is given that 2000 joule can rise temperature by 1 Kelvin or 1 degree. So rise in temperature will be 5832 divided by 2000. So this will be equal to 2.916 Kelvin or degree centigrade. And now, when this 6 ohm resistor gets fused. In that case, only 1 ohm resistor and 2 ohm resistor will be left and they will be in series. So in that case, what will be I? I will be 6 upon 3, that is 2 ampere. Now, heat produced through this 2 ohm resistor. So I square RT. So I will be 2 square, resistance will be 2 into time is 15 into 60. So this is 8 into 15 into 60. So that will be equal to 7200 joule. Now rise in temperature. So rise in temperature equal to 7200 divided by 2000. So this will give 3.6 Kelvin or degree centigrade. Thank you for watching.